Hi, so the main topic for this video is about the natural logarithm. Before we get started to derivatives and integration of natural logarithm, there are actually 4 basic rules that we should know. So the first properties of natural logarithm is about the product rule. Let's say we met an expression like ln bx. We can convert it to ln b plus ln x. The second rule, let's say we meet an expression of ln b over x. We can convert it to ln b minus ln x. The third rule, the reciprocal rule. The expression 1 over x, we can change it to negative ln x. And last but not least, the power rule. Let's say we made an expression ln x to the power of r. We can change it to r ln x. See why this is happening? The power r here, we bring it forward before the ln. So that is how we get this, r ln x. Now we move on to the first part, which is the derivatives of natural logarithm. So these are two simplified versions of the formula that we must remember when we want to find the derivatives of natural logarithm. The first one, which is the derivatives of ln x, we simply get 1 over x. And the second formula, which is we want to find the derivatives of ln fx. This means that this term is much complicated than the x term up here. So the derivatives of this, we will get 1 over that function fx times the derivatives of that function. So it's very simple. So we move on to the example of these derivatives of natural logarithm. This is the first example of question that if we want to find the derivatives of it, we can use both of the formula that I have mentioned before. So to find the derivatives, which is dy over dx. So as you can see, after the terms ln, the terms inside the square bracket is actually the fx term. So if we want to find the derivatives of it, we simply get 1 over that term, which is ln x. But we must also remember, we have to differentiate these terms, which is we will get 1 over ln x. And last but not least, we still have to find the derivatives of this part, and we will get 1 over x. So this is the answer, but we can rewrite it to make it a better answer. We can write it as 1 over x ln x ln x. So this is the answer. This is the second example. When we see this kind of question, we can see that there is a constant in front of the ln terms. So we can put it at the front part first, so we will not mix it up. And then we move on to the ln term up here. We can see that when we refer back to the quotient rule, we can change from this form to this form. So that is what we are going to do. We're going to change it to ln 1 plus x minus ln 1 minus x. And we can start finding the derivatives of this equation. As the constant 1 over 2 still remain at outside, and the derivatives of ln 1 plus x, we will get 1 over 1 plus x, and the derivatives of this part, we simply get 1. And then we minus the derivative of ln 1 minus x, we simply get 1 over 1 minus x. And the derivative of this part, we will get negative 1. After this is just the simple algebraic. The constant can still remain outside. And if we want to minus any fraction, we have to make the denominator the same. So I have to multiply both of them with each other. 1 plus x times 1 minus x. For the numerator part, I will get 1 minus x minus 1 plus x, and we simply, and then because there is the negative 1 over here, we will get positive sign over here. And then we can make some simplification. Right up here, 1 plus 1, we simply get 2. Minus x plus x, 0. So we settle for the numerator. For the denominator, we have to expand this. We simply get 1 plus x minus x squared. There is more simplification that we can make. We cancel these 2 out. We simply get 1 over 1 minus x squared. And that is the final answer. Now we move on to the integration of natural logarithm. So as you all probably know that integration is just the opposite of differentiation. So that is why I have included the two formulas that I have showed to you earlier. So you can see the relation between these two formulas. So let's say in the earlier part, I showed to you that if we want to find the derivatives of ln x, we simply get 1 over x. But now the case is we want to find the integration of 1 over x. So the answer will be ln x plus some constant. And you can see here, it's actually just the reverse process of finding the derivatives. The second formula also is the same to the other formula that I have showed to you earlier here, which is if we want to find the derivatives of ln fx, we simply get 1 over fx times fx. And if you simplify this, you will get the derivatives of fx over fx. To integrate this form of equation, the answer that we will get will be ln fx plus some constant. Again, you can see the relation is just the reverse of the differentiation. This formula, it will make it easier for you to tackle the questions without have to remember lots of formulas. So I will show you the types of questions that involve the integration of natural logarithm. First example is very simple, but the trick is there is limit in this question. So to start with, we want to find the integration of 1 over x. So we simply get ln x. Yes, that is very simple. But remember, we have to include the limit, which is -2 and -3. So what we have to do is we substitute it into the question. So we will get first ln -2, and then we minus with ln, we substitute the x with -3. But remember, if it's involving ln, the number must be positive. So we'll get ln 2 minus ln 3. So we refer back to the quotient rule that I have mentioned before. We can change from this form to this form. So we want to change it. We will get ln 2 over 3. And that is the final answer. This is the second example, and this time the question is in the fraction form. So don't panic when you see this kind of question. You just have to know a few steps to tackle this question. So first, you look at the denominator side, which is below the line. You have to find the derivative of this part. And in this case, the derivative is 8r. And this 8r actually is equal to the upper part of this function. So recall back to the formula that I have shown you earlier. If the function is in this form, the result of the integration will give you the ln of that function plus some constant. So in this case, the answer for this question, it will result in ln of the function, which is ln 4r squared minus 5. And don't forget to add the constant. This is the last question, and it involves the integration of trigonometric function. So when we see this type of question, we want to make the trigonometric into a simpler form. And in this case, it's tangent 3x. So I will make it into simpler form, and I will change it to sine 3x over cos 3x, because it will give us tangent 3x. So when it is already in this form, I figure out that I can use the substitution method. So I want to let u as the below part of the function, which is cos 3x. And when I differentiate this, I will get negative sine 3x times 3 from the x part in here. So, and then, yeah, I will get sine 3x. Okay, I will rearrange this into negative 3 sine 3x dx. Okay, but then I don't want these whole terms. I just want sine 3x dx to be replaced here. So I want to make this negative 3 disappear. What I have to do is I divide everything with negative 3. Like here, I divide it with negative 3, and all the terms here, I divide it with negative 3, I will get sine 3x dx. Now I can start substituting the u values here into the original equation. The integration now will be 6 over, I replace the cos 3x with u, and then sin 3x dx will be equal to du over negative 3. I can make some simplification here. I can cancel out negative 3 and 6. It will give me negative 2. I can put it outside. So what's left inside the integration is 1 over u du. But before I forget, I have to change the limit, because now I'm integrating to the respect to the u, not to the x. So initially, when x is equal to pi over 12, so I have to substitute this x value into u up here. So my u value will be 1 over square root 2. When x equals to 0, my u value will be 1. So I can change the new limit into 1 over square root 2 here, and 1. So remember, when we want to integrate something with the terms of 1 over u du, we will simply get ln u. And that is my limit. The next step, we just have to substitute the u with the values. So it will be ln 1 over square root 2 minus ln 1. And these terms here, I can break it down again. I can get negative 2 inside the bracket, ln 1 minus ln square root 2, and minus ln 1. I can cancel out ln 1 here, because ln 1 minus ln 1 will result in 0. So what's left is negative 2 times negative ln square root 2. The final answer will be 2 ln square root 2. And that is the final answer. So that is the end of our video. Thank you for watching this video, and please don't hesitate to comment on our video. See you!